Very definitely back to the WJEC curriculum for this last particular movie. Enantiomers are often called optical isomers, not because they look different, all isomers look different, but because of how they behave with certain types of light. In a sentence, and I'm not even going to write this sentence, but different enantiomers rotate plane polarized light in different directions. Now let's actually pull that apart. First of all, what do I mean by plane polarized light? Well, first of all, here's the light wave, a very sort of weeny light wave, and it's any old light wave. If I look at it, right, as that wave is coming at me, it's just going to look like a straight line, okay? So a straight line right here just means the wave coming straight at me, okay? Now, normal light, if I was to look at it with that normal light coming out at us, you're going to have these waves at all different angles. Okay, so nothing special with the colors. I've also limited the picture here because I only have a finite amount of time to draw it. But essentially, there would be an infinite array here of all the different orientations of this wave of light coming at me. Now what we can do is we can polarize that light. That is, pull out certain types of light, certain orientations of the light coming at me. And if I do plane polarization, then I will just pull out one particular one. So in this case here, I've plane polarized it just to get this one out. I could have had a different plane polarization and pulled that olive one out, or the green one, or the blue one, but I'm choosing this one. Okay, so when we have enantiomers and we want to distinguish between them via their physical properties, we take light, we pass it through a device that polarizes the light, that essentially just allows one orientation of the light to go through. Now, if we do that and we shine it on one enantiomer, then it will bend the light in one direction. So using our example here, the light starts off being vertical after it's come through the polarimeter, and then we pass it through the first enantiomer, a solution of the first enantiomer, a sample of the first enantiomer, and it turns it in one direction. And I'm going to pretend that's plus 15 degrees, okay? Nothing special about the 15 degrees. Different compounds rotate by different amounts. Then if I take the second enantiomer and pass that light through it, then it will again rotate the light by the same amount. So in this example, minus 15, about 15 degrees, but in the opposite direction. So it's minus 15 degrees, okay? One enantiomer rotates one way, one enantiomer rotates the light the other way. We name these based upon that physical property. So enantiomer 1, in my example, rotated it clockwise, so it's called dextro-rotatory. Enantiomer 2 rotated it counterclockwise, so it's called levo-rotatory. Nice words. And the abbreviations for those used to be D and L. However, as you will see when you get into biochemistry or biological classes, sometimes people, instead of using R and S, which is rectus and sinister, for what the structure actually looks like, okay, they'll use D and L, capital D and capital L, which of course is very confusing for a little d and little l, because which way they rotate light does not depend upon what their structure is. You can't say R is always dextrorotatory, S is always levorotatory. They are two different properties of enantiomers. One is associated with the structure, R or S, the other is associated with what they do with light, dextrorotatory or levorotatory. But anyway, to avoid that possible letter confusion, you usually see plus and minus used. The enantiomer that's called plus blah 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 is the one that turns light in a clockwise direction. The other one, its mirror image that is non-superimposable, rotates the light in the opposite direction, so it's called minus blah blah blah. Now sometimes you'll have a 50-50 mixture of both enantiomers. If you do that, well then it cancels out and the light just looks like that. A 50-50 mixture is called a racemic mixture. So that's a word you'll see a lot. A racemic mixture is when you've got a mixture of two enantiomers, both enantiomers of a particular compound. And the symbol used for it is very imaginatively plus and minus, because of course it contains the plus, the dextrorotatory enantiomer, and the minus, the levorotatory isomer. We'll encounter enantiomers as we keep going through the course. Quite a few of the things indeed that I'll take you a little bit beyond the A-level spec. We'll have to get really, really good at this whole RS and racemic mixtures and pluses and minuses and not muddle them up. So anyway, hope this was okay, and I look forward to chatting with you all on the worksheet about it.